In this section, we discuss about interaction of radiation with human body for radiographer and radiotherapy technologist. Introduction: Ionizing radiation play a central role in modern medicine and particularly in diagnostic radiography and treatment in radiotherapy. Understanding how radiation interact with human body is essential for safe imaging practice, accurate diagnostics, effective cancer treatment, and radiation protection. The interaction of radiation with body tissue occurs in a sequence of physical, chemical, and biological events, ultimately determining both beneficial medical outcome and potential risks. Nature of ionizing radiation. In medical practice, the most common used ionizing radiation are X-ray, gamma ray, electrons, and high energy photons. These radiation have sufficient energy to remove electron from atom. A process is known as ionizing radiation. These property distinguish ionizing radiation from non-ionizing radiation and explain its ability to alter biological structure at the cellular and molecular level. Physical interaction of radiation with tissues. First, we discuss about photoelectric effect, then Compton scattering, then coherent scattering, and pair productions. When radiation enters the human body, it does not pass through the harmlessly. Instead, it interacts with atoms in tissues and transfer energy. The main physical interaction mechanism for X-ray and gamma ray are as follows: photoelectric effect. The incident photon is completely absorbed and an inner shell electron is ejected. This interaction is most likely in high atomic number material such as bone contrast. It crucial for image contrast in radiotherapy and CT and related diagnostic radiotherapy. Next, we discuss about quantum scattering. The photon transport part of its energy to an outer shell electron and change direction. The interaction predominant in soft tissue at diagnostic and therapeutic energy. It content to scatter radiation, image disintegration, and patient dose. Then in the slide not available, in one or two line we discuss about coherent scattering, which occurs at very low energy and has minimal ionization effect. It has a little impact on image formation or dose. And then we discuss pair production occurs only at very high photon energy above 1.02 MeV, which is mostly used in radiotherapy and is relevant mainly high energy radiotherapy beams. The interaction generates secondary electrons which are primarily responsible depending energy locally in tissue. Chemical stage. Then we discuss chemical stage. Formation of free radicals. Human cells are composed of approximately 70% of water. When radiation interact with water molecules, it causes radiolysis of water, reduce highly reactive free radicals such as hydrolyzed, hydrolyzed OH or hydrogen H. These free radicals are unstable and react rapidly with nearby biological molecules. This chemical stage is short-lived but critical. It is linked the physical interaction of radiation to its biological effects. Then biological effects of radiation. In biological effects of radiation, the most important biological target of radiation is DNA. Radiation can damage DNA in two main ways. First, direct action, then indirect action. First, we discuss about direct action. Direct action radiation directly ionize DNA molecules, causing single stranded or double stranded breaks. Indirect action, free radicals produced from water radiolyze interact with DNA, proteins, and cell molecule, leading to molecular damage. Double stranded DNA breakage are most lethal or difficult for the cell to repair. In the 6 number slide, we will discuss about cellular response to radiation damage. After radiation exposure, cell may respond in several ways. Successful repair, the cell survives and function normally. Misrepair, intact repairs lead to mutation which may contribute to carcinogenesis. Cell death, the cell undergoes adopt or less ability to driven reproductive death. Cells that divide rapidly have less ability to repair damage. Bone marrow, gastrointestinal epithelium, and tumor cell are more representative. Tissue and organ sensitivity. Different tissues show varying sensitivity to radiation generally. High sensitivity, bone marrow, lymph node, and reproductive organ. Moderate